Good evening, everybody. This is Professor Ayorinde welcoming all of you to the first review session for the fall 2012 semester. I do notice we have a lot of you already joined us, so let me go ahead and acknowledge each one of you before we start the session. I see we have Brianna Neal, we have Tivon Cummins, Deja Brown, Dulcie Lawless, we have Godfrey Adejumo, Ines Kifando, Janae Jones, Yakinda Kepas, Kinney Walker, Makinda Saki, Mohammed Meki, Ogechi, let me see here. Okay, Jacinda Kepas. Let's see, we have Janelle Radiri, we have Kinney Walker, Makinda Saki, I think I said those already. Okechi Megara, Oyin Olusheye, Praveen Chika, Rahul Sharma, Rita, Sandra Onyekere, Spencer Mitchell, Tila Wright, Tiffany Farrell, Trudy Wilson, and I think that's all of you. I want to welcome all of you to the first Organic Chemistry 1 review session for the fall 2012 semester. Okay, since this is our first session, I do want to let you know that anytime you feel like asking me a question, you could raise your hand electronically. There is this electronic hand raising here. Now, if you can see my cursor, give me a happy face. The happy face is right here. If you see my cursor, give me a happy face. Okay, can you give me a happy face if you see my cursor? Okay. Okay. Also, you could send me your questions and or comments through the chat window. The chat window is right here, so you could simply just type whatever you want. Okay, for example, if I want to type welcome and then enter, that will now send welcome to all of you. So if you want to ask me a question or send a comment, you could also use the chat window. Of course, you could always turn on your mic to ask a question. Okay, to get the session started, I'm going to call on Tudi. Can you go ahead and read this question for us?
Draw a line bond structure for is it C2H4, no rings?
Yes, it's C3H4.
Okay.
Thank you. Draw a line bond structure for C3H4. To do that, you have all of the tools that you need here. You pick up the bond. I will simply want to draw, you have 3 carbon atoms. Draw 3 carbon atoms. Now they tell you there is no ring here, and the formula is C3H4. So now we only have 4 hydrogen atoms in this molecule. So therefore, if we want to draw a bond line structure, it has to be this here. Okay, that is your line bond structure. In other words, I now want to indicate the hydrogen. I pick up an hydrogen atom right here. I place the hydrogen here. I place another hydrogen here. So that takes care of 2 hydrogen. Then I come here, I draw another hydrogen here, and another hydrogen here. Now, if you all see what I've done, now give me a happy face, or you could give me a green check. The green check is right here. Okay, if you all see that, give me a happy face, Or give me a green check. Okay, very good. Okay, the jar. Okay, everybody sees that. Great. Okay, so now you have the line bond structure that we have drawn here is consistent with the formula that we have, which is C3H4. Okay, so we have 3 carbon atoms and 4 hydrogen atoms. Okay, is there any question on this before we move on? Okay, let us draw another. Let me go up here. Okay, let me see. Can I call on Spencer? Is your mic working? If your mic is working, can you read this question for us?
Can you hear me?
Yes, go ahead.
Hello?
Yes.
Convert the following molecular model into a molecular formula without subscripts and with elements in order CH followed by others in alphabetical order. I can't see. I'm sorry.
Okay, very
Examples.
good. That's good enough. That's good enough. Okay.
Okay.
What they want to, yes, thank you. What they want you to do here is to draw the molecular formula for the structure. This is a fairly simple case of just knowing what the structure looks like and all of the atoms that are present in the structure. Look at this here. Okay, can anybody tell me, you could just type this to me through the chat window, how many carbon atoms do we have in this molecule? The gray is carbon and the white is hydrogen. Excellent. All of you got it right. 3. So you have 1, 2, 3. So therefore, what do? We type in C3, okay, for 3 carbon atoms. And then you follow that up with hydrogen atoms. So how many hydrogen atoms do we have in this molecule? The white is hydrogen. Okay, excellent. Okay, everybody says 6. Okay, that is 1, 2, 3, 4, 5, and 6. So you have 6 hydrogen atoms. And then we have the last atom that we need to identify here. That is the red here, which is the oxygen atom. That is oxygen. So therefore, we have oxygen. So this formula here therefore becomes C3H6 with 1 oxygen. By the way, these questions are from your OWL. This is the same type of question that you have to do in your own work assignment. Okay, at this point, before you guys came in, I have loaded, okay, somebody has a question. Does it matter what order the atoms are in? That is Kine Walker asking that question. Yes, it matters. The order is carbon first, then you follow that up with hydrogen, and then you follow that up with the other atoms in alphabetical order. For example, if you have nitrogen in this molecule, nitrogen will come after the hydrogen and will come before the oxygen atom. Okay? Okay. Is there any other question? Okay, no other question. Okay. Okay, very good. Okay, now before you guys came in, what I did, I loaded some of these questions in OWL into my notebook, so I will be able to write using my notebook. So I'm going to go to my notebook now and pull off those questions. Just give me 1 second. By the way, a lot of people joined us since we started. You are all welcome. If I have not acknowledged you yet, I will acknowledge all of you at the end of the session. Okay, let us do this together. Okay, I'm going to call on each one of you. Oh, somebody asked some question here. Janelle, let me see this question here. Janelle Radiri said, wait, so what is the order again? Oh, okay, you want to know the order again. Okay, let me write it for you. The order is carbon will become first, then you follow it up with hydrogen. Then after that, you then use alphabetical order. For example, say I have this molecule here. Let me say I have this molecule here. This here, CH3, CH2, with CH, with nitrogen, with this here, CH2, and OH. Okay, supposing I ask you to give me the molecular formula for this molecule, what will it be? What will it be? Give me the molecular formula. You guys could send it to me through the chat window. Okay, this question, I'm trying to answer Janelle Radiri's question. Okay, what will it be if I ask you to give me the molecular formula for this molecule? Okay, carbon, but I want the formula, the complete formula. Give me the, okay, let us see here. Somebody, okay, great. C4H11, okay, you have, it should be NO because in alphabetical order, N comes before O. Okay, great. So you guys got it. C4, that's C4, how many carbons here? 1, 2, 3, 4. So that is C4. So the way it goes, you do carbon first, then you follow that up with hydrogen, just as you guys have told us now. How many hydrogens here? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is 11 hydrogen. Then you now follow that up in alphabetical order. In alphabetical order, that is nitrogen comes before oxygen. And that is the order. Okay. There is some other question here. Let me address those other questions before we move on. Okay. Then Taylor Wright asked carbon, hydrogen, and then the other atom. Oh, okay, that's good. Thank you, Taylor. You are trying to answer the question for me, for one of your colleagues. Oh, okay. Okay, very good. So you guys got it right. Okay. Let us move on then. Now, you can take this out of here. Okay, let me call on somebody to read this for us. Amber, is your mic working? If your mic is working, can you read this question for us?
Hello.
Yeah, go ahead.
Convert the following molecular model into a molecular formula without subscripts. Only the connections between the atoms are shown. Multiple bonds are not indicated.
Okay, very good. Thank you. Okay, so it says convert the following molecular model into molecular formula. So this is similar to what we just did. Okay, can you guys go ahead and do that for us and send it to me through the chat window? The first thing we need to know, how many carbons do we have here? Okay, 3 carbons. Very good. Okay, so let us have the formula then. This green here, this olive green, this is chlorine. This is chlorine right here. So what will be the formula? C3H5 and 1 chlorine. That is correct. You have C3 and then you have 5 hydrogens and then you have the chlorine atom. Okay, very good. Okay, so let us move on. Okay, this is a little bit more challenging. Okay, now says, let me see who can read this for us. Somebody who are not talking yet. Brianna, could you go ahead and read this for us? If your mic is working.
Can you hear me?
Yes, go ahead.
List the numbers of atoms which bear lone electron pairs.
Okay, that's good. That's good enough. Okay, thank you. Okay, what they want us to do here is to list the number of atoms. In other words, identify the atoms in this molecule that have what we call lone pairs of electrons, or sometimes we refer to as non-bonding electron pair. Non-bonding electron pairs. Okay. Okay, in this case, the same thing, they call it lone pair of electron pair. Lone pair of electron. Both of these mean the same thing. Now, what does that mean? Okay, in order to answer this question, let me go ahead and write this structure here in two-dimensional form for you. Okay, starting with this carbon right here. Okay, so I will say I have that carbon is bonded to 2 hydrogen, and of course it is bonded to oxygen, and that oxygen is bonded to hydrogen, and then we have that carbon is also bonded to this carbon here, which is this here, bonded to hydrogen, and that carbon also bonded to oxygen, and the oxygen bonded to hydrogen. So now we have this carbon here. Now let us now look at this carbon. It's now this here. In a 5-member range, we have oxygen here. You have that carbon there, another carbon here, another carbon there, this carbon there. And now we have this here contains oxygen. This is oxygen also. And this carbon here is attached to oxygen and also attached to hydrogen. And this carbon here, this one here is attached to oxygen, and then oxygen is attached to hydrogen. Okay, what else? I think we got everything now. Oh, okay, this carbon here is attached to hydrogen. Now, if you see what I've drawn now, give me a happy face. If you see what I have drawn here, give me a happy face. Okay, what I've done here is to draw this same molecule here. What I've done is to draw this same molecule here in this two-dimensional form here, so we can see this better right here. Now, the question they ask is, list the numbers of atoms which bear lone electron pairs. This question is testing your knowledge of the octet rule and also, of course, of valence. Okay? Let us take a look at starting from this oxygen. Let us start with this oxygen. Okay, supposing I ask you, does this oxygen have an octet of electron the way it is written? Yes or no? No, exactly. The way it is written here, it does not show an octet of electrons, because if you look at this, we have 2 electrons here, then we have 2 electrons here, so that is a total of 4 electrons that is surrounding this oxygen. Therefore, how many more electrons do we need in order for oxygen to have? It needs 4 more. Exactly. And we know that each orbital will take 2 electrons, so therefore, we are going to have two pairs of non-bonding electrons, one pair here and another pair here. Okay, that is the question they're asking you here. List the atoms which bear lone electron pairs. In other words, they want you to identify those atoms that have what we call non-bonding pairs of electrons. Non-bonding electron pair. Okay, or as they have it here, lone electron pair, the same thing. Okay, so we identify this oxygen. Okay, can we do the same thing with this oxygen? Yes or no? Can we do the same thing with this oxygen? Yes. So this also has two pairs of non-bonding electrons. About this carbon, does this carbon need pairs of? No. Very good. Carbon is happy. About this carbon? Yes or no? No. Okay, very good. Okay, the same thing with this carbon. This carbon doesn't need anything. Now let us come to this oxygen. About this oxygen, what do we need here? How many pairs of non-bonding electrons? How many? You need two pairs. Okay, 4 electrons. Okay, good. So we have one pair here, another pair here. So it needs 4 electrons in order to satisfy the octet rule. How about this oxygen here? About this oxygen here, what does it need? It needs how many pairs? 2 pairs. Okay. Okay. Now, let us now look at, we are going to come back to this oxygen, okay? Let us look at this carbon. Is anything wrong with this carbon? Does this carbon have the correct valence? This carbon? No. So what about this carbon? Does this carbon have the correct valence? No. So what do we need to do between this carbon and this carbon? A double bond. Excellent. Excellent. So therefore, we put a double bond here. So in this question here, they are testing for your knowledge of valence. They are also testing for your knowledge of the octet rule. So you need to keep both very handy. Okay, so this carbon is happy. The valence is satisfied. This carbon is happy. It has the full valence. Okay, about this oxygen, let us look at this oxygen. What do we need for this oxygen? Is the valence okay with oxygen? Yes or no? Is the valence okay with oxygen? The valence for this oxygen. What is the valence of oxygen? The valence of oxygen is 2. In other words, oxygen needs two bonds. Okay, so it has 2 bonds here, so the valence is okay. About the octet, yes or no? No. So therefore, how many pairs of electrons does it need to satisfy the octet? 2 pairs. Okay. So we therefore place 2 pairs here. 1 and 2. Now let us come to this carbon. Let us come to this carbon. Does this carbon, is the valence satisfied? Does it have the correct valence, this carbon? No. How about this oxygen? Does it have the correct valence? No. So therefore, what do we need? A double bond. Okay, great. So you guys got the idea. You have to place a double bond between this carbon and this oxygen. Now keep in mind that all we are testing here is your knowledge of the octet rule and valence. Those are the 2 things we are testing in this question. Now, okay, so as far as this molecule is concerned now, carbon is happy. It has the correct valence. It also has the correct octet. How about oxygen? What do we need to do with oxygen? 2 pairs of non-bonding electrons. Good, good, good. Okay, and that is the question they ask you. They ask you to list the number of atoms. In other words, identify those atoms that have non-bonding pairs of electrons. So in this case, it is this oxygen, which is number 10, according to what they have here. If you are doing this in R, you will write number 10, then number 8, which is this oxygen here, and then number 5, which is this oxygen here, and then number 16, which is this oxygen here, and then number 14, which is this oxygen here, and then number 12, which is this oxygen here, and I believe those are all of the atoms that need non-bonding pairs of electrons. Now, if you understand what we have just done now, give me a happy face or give me a thumbs up. You could go right here, pick up any one of these. Okay, very good, very good, very good. Okay, let us move on. Okay, now okay, now I think we've done this already. Okay, let me get it. I think we did this already in the last question, so but let me get somebody to read this anyway. Okay, let's see who has not talked yet. Deja Brown, can you read this for us if your mic is working? If it is not working, just let me know through the chat window. Okay, not working. Okay, very good, very good. Okay, about Siobhan Cummings, if your mic is working, can you read it for us? If it is not working, just let me know through the chat window. Okay, good. About Demi Oshundeko, if your mic is working, can you read this for us? If it is not,
hello?
Yes, go ahead.
List the atom pairs in ascorbic acid, vitamin C, below that are connected by multiple bonds. Hint, consider the number of bonds attached to an atom in the J-mole image compared to the valence of that atom.
Okay, thank you. Okay, so what they want you to do here, this is the molecule that we have been given right here. I believe we've solved this problem already in the last session, the last question that we answered. The question is, list the atom pairs in ascorbic acid, which is vitamin C, this molecule here, below that are connected by multiple bonds. We already know that. So, okay, let me ask you, which ones are connected by multiple bonds? Okay, let me give you, run through them for you. Okay. 2 and 3, are they connected by multiple bonds? Yes or no? Yes. Because just like we did before, because the valence of carbon here is not satisfied, and the valence of this carbon is not satisfied, so we place a double bond between them in order to satisfy the valence, and therefore you have a double bond between 2 and 3, and that is what they want you to do. The same thing happens here between 4 and 16. There is a double bond right here because of the valence of carbon here must be 4, and the valence of oxygen must be 2. And that is why we need to put a double bond here. And that is what we did in the last one. If you look at it, we already did that. You see, it is the same structure they're giving you. They are simply just asking a different question. It just so happened that we did that already in this particular problem. So you see the carbon double bond and the carbon oxygen double bond. Is there any question on this before we move on? Okay, let me go to the next one. Okay, no question. Good. So we are moving right along, so we will be able to get out of here at 9 p.m. Okay, let me see here. Who can I call on? Let me see. Okay, Glenisha Smith, is your mic working? If it is working, read this for us. If it is not working, just let me know through the chat window. Okay. About Glenn Gladney, can you read this for us if your mic is working? If it is not, let me know through the chat window.
Specify hybridization of designated carbons of the model.
Okay, very good. Thank you. Okay, so what they want us to do here is to specify hybridization at the designated carbons of this molecule here. In other words, they have identified certain some of the carbon atoms here, and what they want us to do is to identify the hybridization. Okay, so let us start. But you see, this is fairly tricky because for this here, in order for you to determine the hybridization, you need to write the complete structure for this molecule. So let us go ahead and write it out first. Let me go ahead and write the structure here. Right here, we have a 6-member ring. Okay, so let us do that. Carbon, carbon, carbon. Okay. That is our 6-member ring. Then they have hydrogen here. Then they have another hydrogen here. Then they have oxygen, and then attached to that is hydrogen. Then we have hydrogen here. So this is a fairly tricky question. It's not as simple as it looks, but it's something that all of you can do. Okay, then on this carbon here, we have the blue, by the way, is nitrogen. And then attached to nitrogen is hydrogen. And then we have the nitrogen is attached to carbon. And attached to that is oxygen. And then we have attached to this carbon is a carbon which is attached to 3 hydrogen atoms. Okay, this is the molecule they have given us, and this is the structure they have given us. But what they did not tell you is that this is not a complete structure, so they expect for you to recognize that because you need to think of the fact that you need to worry about the valence and also worry about the octet. So let us start taking a look at this molecule. This carbon here, does it have the correct valence? Yes or no? No. How about this carbon? No. So what do we need to do? What do we need to do? Between double bonds. Great. So we need to place a double bond here. So this carbon and this carbon, they are happy right now. Let us take a look at this carbon. And this carbon, what do we need to do? Are they satisfied with the valence? So what do we need to do? A double bond. Okay, so these are the kind of things you have to think of. Okay, so this carbon is happy. This carbon is happy with respect to valence, also with respect to octet. About these two carbons, this carbon and this carbon, we could tell right now we need double bond, right? So we place a double bond here. Okay. Now about nitrogen, is nitrogen happy? Yes or no? Does it have its valence? Okay. If it has its valence, does it have its octet? No. So what do we need to do on nitrogen? What do we need to do? A lone pair of electrons. Excellent, excellent. So we need to place a lone pair of electrons right here. Okay, now, let us now come back to this carbon. Okay, let us look at this carbon. Does this carbon have this complement of valence? No. About oxygen, does it have its complement of valence? No. Oxygen needs 2 for valence. Carbon needs 4. So we need to now place a double bond here. Okay. Now, does oxygen have the octet now, as the way it is written? No. So what do we need to do? 2 pairs of non-bonding electron right here. Okay. How about this oxygen? Does this oxygen have the complete, the full octet, the way it is written? No. So what do we need? What do we need? 2 pairs. Exactly. 2 pairs. Okay. So now what is the question they want us to answer? Specify hybridization at the designated carbons of this model. Okay, let us start. Somebody just joining us, Rudolph Brown. How are you doing? Welcome. Okay, now, let us start with this carbon here. What is the hybridization? Just let me know. You give me the hybrid. Okay, sp2. Great. sp2. sp2. How about this carbon? sp2. Okay, you guys got this hybridization down to a science. Very good. sp2. And you all know why it is sp2. sp2, any atom, any carbon atom that is attached to 3 other atoms will be sp2 hybridized. Okay, this carbon is attached to 3 other atoms, and those 3 other atoms are this here, this hydrogen, this carbon, and this carbon. And so we can say the same thing about this carbon also. Okay. Oh, somebody say they joined the session. Okay. Okay, about this carbon here. sp2. Okay. About this carbon here. sp2. Okay. Okay, now, how about, okay, the same thing with this carbon. So we know this is also sp2. How about this carbon here? That carbon, sp2. Okay, very good, very good. Now, I want to now ask you, I will tell you something that we did not do in class, but consider that anytime we have this session like this, this is part of your class session. So far, we have been talking about hybridization for carbon atoms. But the same type of hybridization we could have with other atoms, like oxygen, nitrogen. For example, if you have this, if I have, this is water molecule right here. This is water molecule, okay? So to complete the structure of water molecule, what do I need to do with oxygen? How many non-bonding pairs of electrons do I need? 2. Okay, so I place 2 electrons here and 2 electrons here. Now, this is the information that I want to share with you that you need to tell the other students that who are not here today. Of course, this session is recorded, so they will be able to watch it. Anytime you have any atom that has a non-bonding pair of electrons, consider the non-bonding pair of electrons, think of it as an atom. Okay? So in this, with respect to this oxygen here, think of this as an atom. Think of this as an atom. So based on what I've just told you now, how many atoms are attached to this oxygen? Yes, just based on what I just told, 4. Okay, with regard to hybridization, That is the way you look at this. So therefore, if I ask you, what is the hybridization of oxygen? What will you tell me? sp3, excellent. So the hybridization of this oxygen here is sp3 because you want to think of each lone pair of non-bonding electron as an atom. So therefore you have 1, 2, 3, 4. It is bonded to 4 atoms. Therefore it is sp3. Now having said that, therefore, if I ask you, what is the hybridization? What is the hybridization of this oxygen here? What is the hybridization? Excellent. Excellent. That is an sp2 hybridized atom. So this oxygen here, therefore, let me change the color. This oxygen, therefore, is an sp2 hybridized atom. Okay? So what is the hybridization of this oxygen here? What is the hybridization of this oxygen? sp3. Excellent. Excellent. Okay. Very good. Now, supposing on the same token, supposing I say this, supposing I have ask you, what is the hybridization of this nitrogen? Based on the discussion we just had relative to oxygen. What is the hybridization? Okay, okay, you guys are right. You say sp3. Why do you say it is sp3? Can anybody tell me? Either pick up the mic or it has one lone pair of electrons. Excellent. It has a lone pair of electrons. And keep in mind that lone pair of electrons should be considered an atom. Therefore, this is an sp3 atom right here. Now, supposing I have this. Supposing I have this molecule here. What is the hybridization of this carbon? What is the hybridization of this carbon? sp3, very good. Very good. What is the hybridization of this carbon? sp, very good. Now, what is the hybridization of this nitrogen? sp, because this nitrogen here, consider this nitrogen, keep in mind this nitrogen, in order to have an octet, it has a lone pair of electrons right here, and consider that lone pair of electrons as another atom. So therefore, this nitrogen should be considered as being connected to 2 other atoms, which is this and the lone pair of electrons. And that is why it is an sp hybridized atom. Is there any question on this? Okay, so we are moving right along. We have 15 more minutes to go before it is 9. Let's see. We've done that already. Okay, okay. Let me see here. I want to call on somebody who has not spoken yet. Okay. Jamil Jamison, if your mic is working, can you pick up the mic and read this for us? If it is not working, just let me know through the chat window. Okay, apparently it is not working. But Jenny Jones, is your mic working? If your mic is working, can you pick it up and read it for us? Okay, Jenny is trying to write. No, it's not working. Okay, let us see here. Jacinda Kefas,
Now.
is your mic working?
Yes.
Okay, go ahead.
What are likely formulas for the following molecules? Supply the missing digit.
Thank you. That's good. Okay. So now, what they want us to do here, they have given us this molecule here, this A, this is C, they have CH, and then what do? They put a question mark and oxygen. In other words, they want you to provide the number of the digits for hydrogen. Not what they want here, give the molecular formula for this molecule. Okay. What would this be? We have CH. Let us write it out. We have C bonded to oxygen. That's what we have so far. Hydrogen. Okay? Okay. What will, how many hydrogen do you think will be in this molecule? Now, what do we need to do? Okay, let me ask you this. How many bonds does carbon need? 4. Okay. If it needs 4, how many bonds does oxygen need? 2. Okay, so let us satisfy oxygen here, right? Okay, so oxygen is happy. The valence is okay. Now we know that hydrogen only needs 1 bond. The valence is 1, so hydrogen is happy. So how many more bonds do we need on carbon? Okay, so we need 1 more bond. Okay, that 1 more bond has to be hydrogen, because what they told us here, some hydrogen atom is missing. So therefore, this has to be CH2 oxygen, and that is what the question mark here is 2. Do you follow that? If you follow that, give me a happy face. Okay. Keep in mind, all we are doing here, this chapter 1, all chapter 1 is really testing is your knowledge of valence and your knowledge of the octet rule, because these are very important moving forward in organic chemistry. Okay, let us do the next one. B, you have CH, hydrogen, then they have a question mark, and then they have iodine. Okay, I will tell you now, iodine has a valence of 1 because it is in the same group as chlorine. Okay, so what do we need here? Let me erase this. This is B. So we have C bonded to iodine, and then only 1 hydrogen is here. Okay, so what do you think this formula for this will be? How many hydrogen do we need here in order to start? Oh, okay, somebody got it right already. CH3. Very good. You guys know what you're doing. Very good. I like that. So we need to have this in order to satisfy the valence and the octet. Now let me ask you this. Look at iodine right here. Look at iodine right here. How many non-bonding pairs of electrons does it have in order to satisfy the octet? 3. So it needs 3. So it's similar to chlorine. Okay, it has 6 non-bonding, 3 pairs of non-bonding electrons. Okay, that makes 6, and then you have 2 electrons here. That makes 8. So the octet is satisfied. So in this case, this here, this question mark should be 3. And this question mark, of course, we know this question mark here is 2. Okay, so now let us do this one here. This C. Let us do C. Let me erase. Okay, C, what do we have for C? We have nitrogen attached to hydrogen, and then they have a question mark, and then you have oxygen, you have hydrogen. Okay. So they say, okay, what digit do you need to place here for hydrogen? In other words, how many hydrogen atoms will be right here? Okay, so let us see, following valence and octet rules, let's draw the skeleton for the structure, the frame for the structure. So we have nitrogen. At this point, we show that it is bonded to one hydrogen. It is also bonded to oxygen. Our oxygen is bonded to hydrogen. Okay, let me ask you this. What is the valence of oxygen? Is the valence satisfied here? Yes or no? Yes, so we don't need to do anything with oxygen with regard to valence. Of course, we know hydrogen is only a valence of 1, so we don't need to do anything. How about nitrogen? What is the valence of nitrogen? How many bonds does it? 3. So therefore, it is missing a bond here, so that has to be the hydrogen. Okay, so now how about, let us now worry about the rest of the complete structure, the complete calculate structure in this case. To complete the calculate structure, we need to show the non-bonding pairs of electron. So how many non-bonding pairs of electron on nitrogen? Okay, 1, because to do that you need to worry about the octet. About oxygen, how many? 2 pairs of non-bonding electron. Okay, and that will be the complete structure. Therefore, this question mark they have here is 2. Okay? Is there any question on this before we move on? Okay, we're getting close to 9 o'clock, so we're moving right along. Okay, let us see. Okay. Specify. Okay, let me see somebody to call on to read this for us. Okay, Kinney, is that Kinney Walker? If your mic is working, can you read this for us? Kinney Walker, if your mic is working, can you read that for us? Okay.
Specify the number. Can you hear me?
Go ahead, go ahead.
Can you hear me?
Yes, I hear you.
Okay. Specify the number of non-bonding electron pairs that are missing from the labeled atoms.
Okay, very good, very good. Okay, so in this case, okay, I see here. This year I'm going to skip this because I want to save this to the next chapter, chapter 2. Okay, let us work on this one here. The question is to specify the number of non-bonding electron pairs that are missing from the labeled atoms. Okay, so they want you to specify whether you have non-bonding electron here on this carbon and also on this sulfur. So let us start with B. Let us start with A. Do you have a non-bonding pair of electron on this carbon here? Yes or no? No. Okay. What do you have on that carbon? What is missing on that carbon? What is missing? Something is missing though. What is missing? Hydrogen. Okay, very good. So you do need hydrogen here. So essentially, that is this here. It should be hydrogen. And of course here you have hydrogen. You have hydrogen. And then you have this carbon here. you have sulfur, and then this here, you have sulfur, hydrogen. Now, they also ask you, on this sulfur here, okay, how many pairs of non-bonding electron you need on this sulfur? Pairs of non-bonding electron, okay, 2. Keep in mind, sulfur is similar to oxygen. Okay, right there, right there, right there. Okay, how about this sulfur? Okay, somebody said, I don't get the first one. Let me see who said that. Somebody is asking me a question here. I don't get the first one. And when you say the first one, can you, Ines, do you mean this one here? Yes or no?
No. I mean
Which?
the one you drew with the 3 hydrogen and then you have a double bond there. Oh,
Okay.
isn't it a double bond?
This one here? This one?
Yes.
Yes. What I've done is just to draw this. What I've is to draw this molecule here. Let me see, what I've done is to draw this here. Okay? This is what they've simply given you here. It's something like a skeletal structure. It's a combination of, it's a skeletal structure in which this is a carbon atom and then you have hydrogen attached to it. All I've done is simply just to draw it out in a way in which you see the hydrogen atoms. Do you see that?
Yes, I do know. Thank you.
Okay. The same thing here. The hydrogen is missing here because carbon need 4 bonds. That is why all I've done is simply just to draw it out so that you see all of the hydrogens. Okay. Okay. Janelle, do you follow that? Do you follow the explanation I just gave? If you do, give me a happy face. Or if you don't, pick up the mic and... Okay, the question is, this molecule here, this molecule here, I drew this molecule here. All I've done is to draw this molecule here into here. Okay? If you look at this carbon, both Kine and Janelle, and yeah, okay, if you look at this carbon, okay, both of you look at this carbon here. Do you agree that is a carbon atom, yes or no? Okay, if you agree that is a carbon atom, how many bonds does carbon need at this point? It needs 4. Okay, how many bonds do you see here? 2. Therefore, to make up the difference, you got to assume that the difference is hydrogen atom. And that is why I place hydrogen here and hydrogen here. The same thing with this carbon. Okay, this carbon here only has, if you look at it, 3 bonds, but you need 4. So therefore, when you have that, then you have to assume that the missing bond is hydrogen, and that's what I've done here. Okay, I'm glad you guys got it. Okay, so let us move on. Okay, we could do this and then we call it a day. It's almost 9. Let me see somebody to read it for us. Kayla Simon, is that Kayla Simon? If your mic is working, can you read this for us? Okay.
Propose a structure for a molecule with formula C4H6 that meets the following description. Okay, very good. Thank you. Okay, so what they want us to do here is to propose a structure for a molecule that has a formula C4H6. That is the formula. And they say that that molecule has 1 sp hybridized carbon, 2 sp2 hybridized carbon, and 1 sp3 hybridized carbon. Let us do that and then we call it a day. Okay, does anybody have an idea? We know that we have 4 carbon atoms. Do you want me to go ahead and draw the 4 carbons, right? Let me say 4 carbon atoms. Okay, so what do we need to do here? We need 1 sp3 carbon. Okay, we need 1 sp3 carbon. So what do you want me to do for the sp3 carbon? Pick up the mic and talk to me or send something through the chat window.
4 atoms.
Okay, good. 4 atoms, so you want 3 hydrogen. Excellent. Excellent. So you guys say I need to put 3 hydrogen somewhere here. Okay. Okay. So that will be the sp3 carbon. So now we've taken care of the sp3 carbon. Now we need 2 sp2 carbon and 1 sp carbon. What do we do? What do we do? We need 1 sp carbon and 2 sp2 carbon. Okay, somebody said 2 double bonded carbon. Excellent. Okay, you guys got it. Okay, 2 double bonded carbon. Okay, good. Good, good, good. Okay, so you guys say I should have 2 double bonded carbon, which is excellent. Okay, so therefore we have a total of 6 hydrogens. So this carbon here needs 2 more bonds. So I will place 1 hydrogen here and another hydrogen here. Okay, so that carbon is happy. Okay, which other carbon here is not happy? Let me label them. 1, 2, 3. Which carbon is not happy? The 3rd carbon. So that carbon needs an hydrogen. So therefore, I place an hydrogen here. So if you look at this here, the formula we have is C4H6. We have 1, 2, 3, 4. That's C4. How many hydrogens? We have 6 hydrogens. So we meet the requirement of the molecular formula. Now let us see whether we meet the requirement of hybridization. Okay, this is sp3. We all say agree to that. Okay, let me label this again. This is 1, 2, 3. What is the hybridization of carbon number 1? sp2. Good, good. What is the hybridization of carbon number 2? sp. Very good. What is the hybridization of carbon number 3? sp2. Excellent. Okay, so what do they tell us to do? The requirement is that this molecule must have 2 sp2 carbon. That's what we have. This is 1 and that is 2. So that satisfies that. Then also says that it must have 1 sp carbon, and that is this here. So at this point, unless you guys have any other question, we have come to the end of our session today. And I think it has been a great session for being our first session of the semester. So before we leave, let me go ahead and acknowledge all of you who have joined us, who are still with us. I have Agnes Edukere, Alfreda Woods, Amber Emerson, Ashley Ntim Ade, Brianna Neal, Siobhan Cummins, Deja Brown, Demi Osundeko, those Lawless, Giovanni Mowat, Glenisha Smith, Glenn Gladney, Godson Adejumo, Ines Kifando, Jamil Jamison, Jenny Jones, Jacinda Capers, Kela Semen, Kenny Walker, Mata Margaret Cortin.
Johnny.
Say that again. Oh, okay. Okay, Mohammed. Oh, Tiani, I'm sorry about that. I'm sorry. Okay. Mohammed Mehdi. Nadira Mohammed. Ogechi Emegara. My name is Dominic McLeod, and I was present, but computer would. Oh, okay. That's the same signing. Okay. Okay, I see. Dominic, I recognize you also. Olivia James. Oyin Olusheye. Praveen Cheka. Rahul Shema. Rita. I think Rita was one of the other people who joined us. Rudolph Brown. Ryan Chitan Jackson, Sandra Onyekere, Spencer Mitchell, Taylor Wright, Takesha Wooten, Thomas Weaver, Tiffany Farrell, Trudy Wilson. She was one of the other people who joined us. Okay, I do want to say thank you to all of you. I hope we will see you again next Wednesday so we can continue to do this every Wednesday. Since somebody is also sending, so Eddie Rono was here as well, sharing with Giovanni Mova. Oh, okay, Eddie Rono, I do acknowledge you. So you guys enjoy the rest of your evening, and I will see you tomorrow. Thank you all. Before you all leave the session, make sure you log out. To log out, just use the X to the right, the top right corner. You see the exit X button. Just click on that. Then you exit the system. Right here, right here. Just click on that. Then you will exit the system. Okay. For those of you just coming in, the session has just finished. We started the session at 8, and as you can notice, we are just finishing the session.